I'm excited to welcome Parth from Ollama. What's up, Parth?
How's it going? Nice to be here. And nice to see you too.
Great to have you. Great to see you. I know you have some stuff that you want to kind of like demo and walk us through today. So with that, I'll hand it over to you.
Sounds good. I'll be sharing my screen. So before we kind of...
Oh, whoops.
Sorry
about that. Keep going.
I'll just give a quick intro on myself. So my name is Parth. Nice to meet you all. I work at Ollama and work on many different things at Ollama. So a big part of what I work on is structured outputs, kind of the API side as well, and a lot of the tool calling stuff that we see these days. And so for structured outputs, it's a pretty big aspect of kind of what we've been working on. And a big part of what structured outputs is just going from unstructured data where you don't know kind of what format your things are in, and you want to be able to make it more usable. And so personally, I really enjoy using structured outputs because I will have some kind of like image or whatever kind of data, and I want to be able to go into just some kind of data that I can actually make use of. But before that, let's dive into what Ollama is. And Ollama is basically the easiest way to run large language models on your computer. And so I'll just kind of quickly show that around. And so I have Ollama running over here, and we also have a desktop app. So hopefully it's big enough. And so we recently released Gemma 3 along with Google. And so just like any other large language model, you can just talk to it. So how are you? Great. Tell me about AWS Lambda. Fun. So this is a 4B model that's running on my computer completely without internet, just on your laptop, which is really cool. And we make that entire process really easy. And so it's available on Macs, on Linux, on Windows. Pretty much we try to support as much as we can. Cool. So now let's dive into a little bit more along structured outputs. And I'll kind of first walk through what that means and what do things look like. So in a normal kind of workflow of an LLM, you have your forward pass, and I'll be focusing on the areas which are more important to us, which are after the forward pass happens. So this is the model taking in your data and running through the network and seeing and basically producing a probability list. And so that's what logits are. And so these are essentially numbers which the model associates with what should be outputted next. So a model can have varying levels of vocabularies, and vocabularies are just all the different tokens it knows. And tokens are just either words or like slices of words that could be there, but there could be split into THE, and then there could be another token with RE, or the entire word there can also be a token in itself. So what happens is every forward pass, we get a probability associated with every single token. And we use those tokens, and then we sample them. So there's many different kind of sampling techniques that we use, or that are popular kind of in the world of ML. Things like temperature, top K, top P, min P, and each of them kind of have a different effect on the probability distribution of the logits. And you use different techniques for different things. Sometimes you want a bit more confidence in your outputs, and you'll kind of make the probability distribution peak a bit more, where you can get better outputs. Or sometimes you want a bit more diversity in your text, where you'll kind of flatten that entire piece out. And so after the sampling happens, we actually only get one output token back, and then we do this process again and again. So when I ran that model, every single thing that you saw printed out was happening through this process. Structured outputs is a little bit different. And so there's like a key piece in here, which makes a pretty big impact. So first we do the model forward pass and the logits output the same. But at the same time, we do this key step for masking the logits. And so what this means is for Ollama, we kind of use JSON as structured outputs, which means that you can take in whatever data, pass it in, and get structured outputs back. And what we do that for is essentially being able to go from this JSON, figure out what is a valid next state, and then hide whatever tokens don't make sense. So over here, I just kind of highlighted that process a little bit. So for example, we pass in this JSON. You know that you need to see a curly brace first. Curly brace, or you might see a curly brace with a space, curly brace with a new line. All of those are valid. And what happens is the logits kind of get masked away. So only certain logits are valid, or certain tokens are valid for being outputted. And then you'll apply kind of the same sampling techniques as I mentioned earlier, and then you'll kind of get your output back. So in this case, you saw that since we wanted this JSON, even though token 0 had the highest probability, we picked token 1 in this case because that was the only valid token. Now, enough of me talking. Let's actually give some fun demos. And so this is just a very simple demo around structured outputs. Over here, I have a schema that I've built out. The schema is built and defined through Pydantic. You can also define it yourself. It's just a JSON schema. And then over here, the text I want to make into structured output is essentially I have two friends. The first is Ollama, 22 years old and busy saving the world. And the second is Alonzo, 23-year-old and wants to hang out. Return a list of friends in JSON format. So I actually recommend passing your entire schema into the prompt as well, because it kind of helps the model figure out what it should be outputting in, or at least telling it the key name, some values, etc. In this case, because it's relatively simple, I just told it return a list of friends in JSON format. So let's run this. Let's see what it says. And then you can see that I have name, age, and if they're available. So we see exactly kind of what we're expecting, but we're able to kind of get structure from completely unstructured text. And so we see that we get a friend list back, and we have friend info with Ollama, 22, and false, because Ollama is not available to hang out because they're busy saving the world. And Alonzo can hang out, so that's cool, really nice. And you can imagine that, this is super useful for when you have documents you want to parse through and structure really quickly and build out whatever kind of pipelines to be able to do this. Another important thing here is to set temperature to 0. This will always pick the highest probability token, which is helpful, especially when generating JSONs. Cool. So now another thing that you can do with structured outputs is actually with images, which is really fun. So if I go to my desktop, I have a couple images. One is Lightning McQueen because I'm a huge Cars fan. And let's run that through our script. And so over here, I have also done the same. I've defined an object, an image description, same kind of JSON schema that I've defined, but with obviously different attributes that I'm looking for from the image. So said, okay, name, confidence, and attributes, as well as summary, object, scene, etc. Cool. And then I've done something very similar. I said, analyze this image and return a detailed JSON description. And kind of just prompted it for the rest. But again, passing in your schema here is super helpful. Again, set the temperature to 0 and so forth. And over here, you can see exactly kind of what we're expecting. A close-up of Lightning McQueen, animated race car from Disney Pixar's movie Cars. Awesome. And it's able to kind of identify, it has a car, it has eyes, it has a mouth, and kind of describes the image. And for something that's running completely on your computer, I still think that is pretty insane. And the jump models do a really, really good job of image classification. And, it describes a lot of the kind of scenery in the track. Another picture that I have is a beautiful sunset taken nearby from me in Palo Alto. And let's do that one next. Because it's a bigger image, sometimes we get some interesting results. So let's take a look. But it's kind of the same thing. It's passing in pretty much the same prompt and just this larger image. And now we expect the model to be able to parse through it. It takes a bit longer, obviously, because it's larger to go through, but essentially be able to describe the same image in detail. So giving it a second, again, this is running on my computer, so sometimes you have to wait a little bit. But we see exactly, again, kind of what we're looking for, which is foreground features a grassy hill and the sky is ablaze with warm colors. It's really cool how accurately it can grab these kind of details. And now you can imagine, let's say you want to go through a bunch of images and either find text or be able to just describe the image and put it into some kind of structure. So you can use it for so many different things. And it's just a really, really useful tool at your disposal for whatever you may do. And structured outputs in general is just a really useful tool to be able to go from unstructured data to structured data, whether it's text or images, and you can build up all sorts of things with that. Cool. And so a big thing that you can find, so obviously you can go to ollama.com to download Ollama, and you can check out our models page to see all the different kinds of models we have, and you can filter through to see for your capabilities. So some will have tool calling, some will have vision, etc. And then the examples I went through are found in our Python repository, Ollama Python, and should be found under examples and structured outputs image. Awesome.
Parth, amazing. Thank you so much. You really, I'm so impressed with how you cranked through that.
No, of course.
You had one quick question I wanted to make sure you saw from the audience, which was someone asking if you can share the spec for your local HW.
Oh yeah, my computer is a beefy one. I have a 128 gigabyte RAM Mac, M4 Max, so I get to run it fast. But we also take steps. It'll run on anything pretty much, but it's just going to be a lot slower if you don't have a GPU available to you. And then if you are kind of trying to figure out what's best for your kind of setup, we offer a lot of quantization, so we try and fit it on your computer as best we can.
Awesome. Well, thank you so much for joining us today and walking us through that. I'm so glad you were able to be involved in this GLOSAIC marathon day of open source AI.
Yeah, no, thank you for having me.
Awesome. Have a great rest of your